Okay, we're gonna hit the button again. Maybe because we were missing with OBS setting. Now we're live. Now I can talk. So what I had this little starting soon thing, and I hit the go live button over here in YouTube. Now it says end stream, but it said go live. I clicked on it, and then I came over here and I was like, yeah, starting soon. Everything's muted. Let's go. Let's finish our technical difficulties and get going. No, I didn't like that.
Okay, yeah, it looks like you're live now.
It looks like we're live now. Now I can do my intro where we say, look, boys, we have Smart Guy with us, Mr. Eternal Serraid, to do this all over again like a dumbass. He is going to keep me sane while we try to support more complicated ABI stuff in the Laye compiler. On my end, I've set up an issue so I can actually try to be a little bit structured and professional about the way that we're doing this. I've got a separate branch. If we go over here, we are on issue 21's branch. It's great. I have my code open here. Hopefully it is big enough for you guys. I'm going to keep the UI smaller than the actual screen. The way I have this set up, we should just be able to start adding code to this function to do a pass on an entire module at a time to fix its ABI compatibility. So we can, I guess, look at an illustration of the problem that we're facing so that people know what the hell we're doing. Do I have an example? Probably not, other than, like, I have my Soding ball still here.
Soding ball.
Yes, it's great. I copied Soding's ball example for Relib. So we could look through this entire thing, or I could make another smaller example. But the thing that we're looking at here is we've got like a vector2 type and a color type. In LLVM, they're going to look like this. They're just nice aggregate structure types, basically, with no explicit padding because there's no padding needed. These are aligned perfectly as is. These are the two types we're worried about for now. You can see nice fancy padding in a lot of other structs, but not these, no padding. The next thing we want is draw circle. Draw circle takes a vector for the center of the circle, the float for the radius, and the color you want to draw the circle. This is the function we're trying to call. This is a C function. We need to obey the C ABI. The thing that we're having trouble with is when calling this function, you'd expect to just be able to pass a vector2 and a color for each of those things. And fingers crossed, LLVM would be nice to us and understand that the C ABI exists. But according to them, it is out of scope for LLVM because it's LLVM and not Clang. So this actually doesn't work. And we could even go GitHub.com. Is what, like LLVM project, LLVM, or something? It doesn't exist. I have it in my email somewhere, or you have a link.
It should be LLVM/LLVM project, I think it is.
The other way around, yeah.
The other way around.
I have it open on my Firefox somewhere. I'm just trying to do things in Chrome to avoid doxing myself. It's probably a recent issue, but it might not be. So.
Oh well, we get issues every hour, so yeah. You have to scroll down a bit.
A bit, yeah. You can search for like C ABI or something.
You can search for X, maybe like x86 or x64. I think the tag does that. Okay, I would have searched the labels, but sure, that also works.
Is it searching?
No, you can click on where it says label. Not that. No, that goes to all the labels. That might also work, but I meant below that.
Label.
And search for either x86 or x64. I never know which one it is. It's x86. Back in x86. I think I tagged it as that.
I can remove this.
Yeah, that's the second one.
That one. I don't have to go to my here. Tinnitus or something. Let's go. I don't have to go through my email to find it. So we're working on this issue, which is probably not technically an LLVM issue according to them, but here's the details.
Not really an LLVM issue. I've left it open and just in case anyone else has similar questions.
For documentation purposes.
I haven't done that before, so I've left it open.
So this is our color structure. This is a simplified version of what we're trying to do. F needs to, I guess I should really show them eventually what the actual, I don't have an example of what the expected actual code is, but this should still illustrate it. So this is compiling down to 4 registers, 1 for each I8. The expected behavior of the ABI in question is all of these should be packed into an I32. So this clearly doesn't work. Only the first argument basically gets through with a bunch of zeros tacked onto the end, and the other three are ignored by the function.
Yeah.
So this, we need to transform into something that doesn't generate this. We need to do that packing manually ourselves by trying to understand some of the ABI in our IR so that we can generate the correct code. Bit of discussion on why it's not technically in scope, which has happened before. All my research pointed me to the fact that they weren't going to do it, but I was hoping that they would.
Basically, the idea is that, the sentiment is that a lot of people, including Chris, for instance, would very much like to have this in LLVM, especially now that MLII is a thing, because it would be helpful for other front ends as well. But also, it would be quite a big refactor because you'd have to handle that for every ABI. And then it's also the thing that the ABI has even some C++ specific things on it. So some parts would still have to be handled in the front end because LVM certainly doesn't know about whether a C++ struct has a copy constructor or stuff like that.
Yeah.
So,
but for like the C ABI, I feel like that should be so much more standardized. If they happen to overlap, then I can see why that's a problem.
The ABI is for both C and C++.
Right.
There's no separate C ABI.
But if you're calling a C decal anyway, I feel like there should be a way to at least flag it, because it's something that everybody's going to want. Everybody wants to interface with C.
True, a lot of people want C interrupt, though. One solution would be to write wrappers in C and only pass point and integer arguments, because those work fine.
Yeah, which is basically what we're doing anyway to adhere to the ABI, but not for this question in particular. But if we have returning structs, we're probably going to have to implement an SRET as well.
Instead of return. It depends, actually. Small structs are returned in registers as well.
Yeah, so the exact same thing we're doing for parameters, but in reverse for returns. If it fits for a parameter, it probably also fits for a return. So that's the problem we need to solve today. We should probably make a test. So I'm just going to do that real quick, because I don't have a dedicated test. I sent you one off the cuff, but let's just call it ABI.log.
I know I posted this LVMI thing, so you can't just copy that.
Huh?
I was going to say you can just copy the code from the issue, but that's LVMIR, so...
Yeah. So what we want is we're going to do something similar to what we did before. We're going to make this a...
And apparently, they hear me twice.
That might be because I've got my mic open. Let me double check that and put my headphones on, see if that fixes anything.
I don't have headphones on. It might be that. I don't know.
I don't hear anything from your end. You were just coming through my speaker, so you probably got picked up. Normally that doesn't happen. Normally it's fine. So I've got just my mic and the regular desktop audio, and I only see a peak when you're talking here and when I'm talking here. So it should be fine. I'm just going to assume it's a headphones issue. Also, I probably need to not use this stupid chat feature because there's absolutely no messages here. So we're just going to, you just close the dockable window. Dock window, cool. So that's useless. I'm going to have to go back to regular ass YouTube chat. Subscriptions, no live streaming. There we go. So raid twice. Whoa, okay, now we're good. So I'm going to mark it no exec for now because I don't want to define a function that does work. We just want to check that our ABI thing does what we want it to do. So we can just do a solid void of F, and we can take a color, C. And we can define a color as a struct, color, I8 RGBA, RGBA, cool. And all we want to do is in main, we want to call F on a color. We can say color, C, and we could initialize it, we could not initialize it, it really doesn't matter. It'll be 0 by default, so this will be valid, not UB code anyway. The other option is just to populate it with a bunch of values, but we're not going to see the results in a function call anyway. So for now, we're just going to do that. So if I knob run with arguments, we want to emit liar just to see what we're doing here. We want O to not a file, but to the standard out. We want to run for test Laye ABI, and there's our current liar here. So it's not colored for some reason. I didn't get the color transfer when I switched to different output methods, but we have our color struct here. We have our function. It's taking a color. Great. We have our main. It's calling this. We've got a built-in memset doing the thing I said it was going to do. And we're loading the value from the address, calling our thing. Cool. So this needs to be translated into a packed int. So we need to do a load of every field or do a bit cast or whatever needs to happen. Probably just a bit cast.
Actually, in this case.
Perfect. Yeah, we can transform this to a load of i32. This needs to accept the i32 argument, which means the signature also needs to change. So the way I was thinking about doing this, if I had proper usage tracking, was to iterate through every declared or defined function, probably just declared. Unless we're defining an exported, which we should probably do, yeah. So every function and seeing if it needs an ABI update. If it does, perform the update and then for all users of it, generate the correct code. So I don't have to iterate through blocks.
What you could also do is go through every function, patch those, and then iterate over every instruction, every function, and patch all the calls.
Yeah, so if we don't have proper usage tracking, that would work, and we could do it regardless.
Would probably be easier.
Yeah, it would be easier. If I do have usage tracking, it's not hard to iterate through all users, because then I can still construct a block builder here and insert and stuff. It'd be functionally the same, but faster if it works. So I'm inclined to at least give it a shot, because I only need to have usage tracking on a call instruction. I don't have to add it to the entire IR. Just if I generate a call, I track users. But that does sound like extra debugging work, so maybe we don't right now. Oh, and this needs to not be Laye CC. It needs to be this one. I'm going to mark it as both foreign and Qualcomm CDECL for maximum correctness. So that put that. So now it is a CCC instead. Calling a CCC. Beautiful. So yeah, let's just.
The default, by the way, you don't have to print that.
I don't have to print that, but I am, just to be. I don't know. It's my IR, not the LLVM IR. So we can look at LLVM IR as well if we want. LLVM should be very similar. So there's this one, and it won't print it if it's CCC. So I do that.
I do hate that you're not printing, that you're printing a space after the opening brace, but not after the before the closing brace in your structs.
That's an accident. It works in Laye, right? I do it correctly here. I just somehow did something wrong here.
Fascinating.
It's fine.
Sure.
So we can look at both of these. I wish it was colored, but it's whatever. So we want to, like we said, find all functions, change their arguments. How do we... Like, I have a high-level idea how to know which ones need to be changed, but,
we'll look at the spec for that to see what we need to do.
Where spec?
Yeah. You're never going to find the one on Google.
Spec. All right.
It says download latest PDF, I think. That's probably what you want. There you go.
All right. System v application binary interface. Woo!
Keep in mind, this is just... I have no idea about Mac, but this is just for Linux. Windows is completely different, of course.
Fuck.
I have no idea about how Windows works.
We'll worry about cross-platform ABI handling later. For now, fuck it.
Let's see, it should be a function calling sequence. Oh, no, parameter passing, actually, so a bit further down.
The back button doesn't work if I click on something.
It's 2 pages, it's fine, you can just scroll down.
Parameter passing.
There you
go. Okay. So, after the argument values have been computed, check. They are placed either in registers or pushed on the stack. Half check. The way how values, the way how just feels weird to me. Values are passed as described in the following sections.
Bit redundant. You could just write how values are passed.
Yep.
And I would write the way in which normally if I were to write the way.
The way in which how. The font rendering here is also strange. Okay, so we have a number of classifications for things. Cool. Integer is the class of the integer types that fit into a general purpose register. Yep. Which is what we're trying to do. SSE is types that fit into a vector register, which is probably going to be our floats.
Mm-hmm.
SSE up is the class consists of types that fit into vector register and can be passed and returned in the upper bytes of it. Okay.
Those are your SIMD vectors,
Okay.
like M1, M256, and so on.
All right, not worrying about that now. We just want floats and we want integers, but anything else in here useful at the moment? Types that will be
Well,
returned by the FP.
XA7 is that's long double, which no one cares about. And complex XA7 is complex long double, which is worse.
Okay. And long double is 80 or 128 or either, or
Sorry, what?
long double, is that always 80 bits? Or
So this is the
anything?
XA6 long double, which is 80, but
Okay.
it in memory it's 128.
Okay. No classes for initializing. Not going to be for padding and empty structures and unions. Cool.
And memory is obvious.
I had the stack. Cool. And this is for C, so these are all the terms that we need to use up to in 64.
Yes, well, the first thing you should actually read is the first sentence on that page, because that's the important
Size of
part.
each argument gets rounded up to 8 bytes. Boom. Basic types are assigned for their natural classes. So this one, yep. So everything is minimum 8 bytes when talking calling convention.
64-bit, yes.
Yep. Cool. Arguments of type whatever. All of these floaty things and decimal-y things are SSE. Yep.
Yeah, everything except the long double.
Right. And then I'm assuming we'll see long double somewhere down here. There it is. Yep. Interesting. So arguments of type these, the 128 ones are split in 2 halves, least significant being one SSE and the most being an SSE up. Okay. Arguments of type 256 are 4 8-byte chunks. Yep. All others are SE ups. Okay. 512. I wonder if it's 1 and 7 or if it's 2 and 6. The
It
least
is 1 and
significant 1 and 7. Beautiful. 64-bit
That basically just means is you pass them in a single vector register.
Okay.
You assign one, so the way that floats are passed is in XMM0 to XMM7. But the way these registers work is XMM0, for instance, is just the lower half of YMM0. So if you need to pass a 128-byte value, but you pass it in, a 256-byte value, you pass it in YMM0, for instance, if it's the first one.
Okay. That mostly makes sense. Struggling to visualize with brain, but mostly makes sense. And then int28, I do eventually want to support int28, but for the time being, it's technically not supported, even though it might pass. Because in Laye, you can just type whatever the fuck you want. This is a 1,238-bit integer.
Actually, by the fact, so you're in luck here. The ABI actually accounts for that, so you're in luck here, because C and C++ have that too now, so it has to.
Woo! I assume it's rounding up, but I have no idea. Bit int, that's right, they do. We're almost there then. So I could start supporting arbitrary bit integers pretty easily once I have this in my brain. So they're treated as if they were implemented long, low, long, high. Okay, with the exception that arguments of 128 are stored in memory must be aligned on 16-byte boundaries. Okay, so it has the alignment of both, not just one.
Well, yeah, sort of. I think it's mostly because a vector register of that size has 16-bit alignment.
Okay. Arguments of this less than 64 are in the integer class. Yep, that makes sense. Greater are classified as if they were implemented as a struct of 64-bit integer fields. Okay, so we just break them up on 8-byte boundaries. Okay, so like an int 256 is 4 longs as if they were in a struct.
Well, an int, yes. A float is different.
Yeah, float would be different for sure. And I'm not supporting arbitrary floats. That is something that doesn't exist if I did like a float.
The ABI doesn't support arbitrary floats either, but it supports fixed vector sizes.
Like you can, I've made sure the highlighting reflects that too. An I12 is valid, but an F12 is an identifier.
I think
16. I'm gonna try to support halves up to 80, not 70, 80, 128, and maybe if ever there were a reason, a 256, but I've only done 16, 32, 64, 80, and 128 as planned features. Okay. Complex. I have no idea what I'm going to do about complex numbers. I want to do something with them, but I don't know what it is yet. So
whatever you do, don't do what C does, where for some ungodly reason, complex numbers are just in like they have wormed their way into every goddamn part of the compiler. They need to be parsed separately. There are separate rules for them in constant evaluation. There are separate rules in the ABI. Complex numbers are just pain. I recently fixed a bug with complex numbers where it turns out we were doing complex multiplication with integers wrong because we were casting the int to a complex float, but you're only supposed to cast it to a float. So you're supposed to do complex float times float, not complex float times complex float. The result is the same, but it generates more operations. So we were doing it inefficiently. So yeah, and that bug has been in Clang for 15 years or so. So yeah, complex numbers are just pain.
Yeah, I have no idea
Whatever
what I'm
you
going
do,
to do.
don't do that.
No idea what I'm going to do.
Make it a struct in the library, problem solved.
They probably will be a struct in the library because
did with standard complex.
Yeah, I don't think Laye is the kind of language where you really want a complex primitive. It's just kind of there to be a thing that exists for the sake of it existing. Now, I've been tempted by vector and matrix primitives, but those are also like complicated enough that they should be a standard library feature anyway. So, like, yeah, those are the kinds of things that I would do as a library feature, but I'm still
pointing
not
out
going
that
to.
LVM does have vector types.
Right, I don't know much about them. So my IR might get vector types, and we might have a special case for, hey, if you use a type named vector that looks like this, or if it's in the standard library thing, I do special handling of it, or I don't know. We'll figure something out. Because I want to support it. Vector operations are going to be great in the future, but at this point in the compiler, I just don't know how they work, so we're not going to worry about it. Aggregate structure types, so this is going to be important. For us, the size of an object is larger than 8 bytes, or it contains unaligned fields.
You read that wrong.
If I skipped the word 8 bytes. Ooh.
So it's 8 times 64. If it's larger than that, just pass it in memory, basically.
Okay, has to go on the stack. Anything smaller could go.
Theoretically, yeah. I'm not sure why they're saying, okay, it's 8 bytes, but that works for floats. If it's integers, it's not going to fit because we only have 6 argument registers, but we do have 8 floating point registers that we can use for arguments. So that's why it's 8 bytes.
Yeah. Beyond this point, it's a guaranteed memory class. It's the important part. Not doing C++ right now. Hopefully that's not relevant.
You can ignore that. That is just for, it says non-trivial for the purpose of calls. That means if it has a copy constructor, move constructor, and so on.
Interesting. Okay. If the size of the aggregate exceeds a single 8 byte, each is classified separately. Okay. Break it on an 8 byte boundary. Each 8 byte gets initialized to a class, no class. Okay. What does that mean? Let's find out. Each field of an object is classified recursively so that always two fields, 18, I'll click on that later maybe. Is that down here? It is. Are considered, that was the end of the sentence. Each field of an object is classified recursively so that always two fields are considered. The resulting class is calculated according to the class of the fields in the 8 byte. If both classes are equal, this is the resulting class. If one is no class, the resulting class is the other. If one is memory, they're both memory. If one is integer, they're both integer. So each field of an object. And by field, are we referring to the 8 byte?
Written a bit stupidly. Basically, you're merging them together.
Right.
You're merging two adjacent struct fields.
Right. Resulting class. And we're talking fields as in each 8 byte chunk?
Not necessarily, no, just struct fields.
Okay, so when we're merging fields into an 8 byte chunk, this is the way that we determine what class of chunk they are.
Not even into
into a chunk.
Well, it depends. I can't. I'm not sure if there is a case where that's possible. It could be maybe if you have like two chars followed by a float, or something strange like that.
With the padding, that would put it as 4 and 4, which would still fit within an 8. So would that make it a float class? Would that make it a? Yeah, that would be a.
Well, let's see. I'm pretty sure that will be packed into one
register, but there's an easy way to find out. We just
Just
take
do
a
it.
look at what lang does.
0 width bit fields are no class. That makes sense.
I'm assuming, yeah, it gets packed into one I64.
Interesting. So that means, yeah, so if you have an int and a float, you're being packed together, the float gets packed in with the int.
Yeah, if you have an int and a float, they get packed into one integer register.
But if you have two floats, they stay float.
If you have two floats, they are, I believe they're packed into a floating point register then.
Yep.
Yeah.
And if one was a float and one was a memory, then the float would go on the stack with the memory.
Yeah.
Okay. Okay, most of this makes sense, but I'll have to see it to really understand it. If one of the classes is any of these things, the memory class is used. Okay. So the more complicated the type, the more likely it's just going to be packed into memory. Otherwise, SSE is used for floats. There you go.
Admittedly, that's why I'm saying complex numbers are dumb. It's because XA7 and complex XA7 is two types. It's long double and complex long double. That's it.
Boy.
Those are the only types that ever belong to these classes.
Wow.
That's why I'm saying complex numbers are dumb. Trust me, they are.
Yeah, they're dumb. Otherwise, SSE, then the post-merger cleanup is done. If one of the classes is memory, the whole argument is passed in memory. Okay. If it's an x87 is not preceded by this, x87 up is not preceded by x87, the whole argument is passed in memory. So it has to have, that's why they specified up here then that these things started with an x87 and then an x87 up, or whatever.
No, that's SSE and SSE up. Again, XA7 is just for long double and complex long double.
Oh, yeah, you're right, that was just for
Ignore
SSE
that
up.
one, please.
If the size of the aggregate exceeds 2 8 bytes, and the first 8 byte isn't SSE, or any other 8 byte isn't SSE up, the whole argument is passed in memory. If SSE up is not preceded by SSE, so this is the one I was talking about, it's converted to SSE. Okay, because it's not an up anymore. Once arguments are classified, the registers get assigned in left to right order for passing as follows.
Okay, you don't have to care about that. That's what LVM does. You only have
okay.
to split them up properly. You don't have to assign them to.
Cool.
Well, the only part where you have to care about it is if you actually do, because if you run out of registers, then you do need to pass it in memory, actually. So
that's fair. Does LLVM handle that part? Because I'm not doing anything explicitly with registers anyway. I'm just giving it the raw data.
Well, let's just say Clang does check if it can be passed in a register, and if it doesn't, it passes it in memory.
Okay.
So you can try and see if LLVM handles it. Officially, I'm pretty sure it doesn't.
Interesting. Alrighty. And then bunch of register stuff.
An example further down, I believe. Oh, that's for return values are similar.
So we'll have to come back here when we do returns. Parameter passing. Oh my god. So is this describing the example below? That's returning.
No, that's
so this is figure 3.5.
I'm sure there is one. There's the result, but no walkthrough of the algorithm on the next page. You can try assigning these, perhaps, as an exercise.
We could make this our second test for full ABI support. Oh my god. Okay. So, where to start with this? Is there more for me to read, or should we just go back up and try to figure out where to start?
Pretty much it.
So somewhere up here, right? Well, here's parameter passing.
So in chat, Mr. Mugame is asking what happened. Does it make a register or crash? It just does something. It probably won't crash, but it will do something. Like, for instance, if you pass a struct that contains 4 I8s, LVM will just split that, but then also extend them and pass them as 4 I32s, which is not what you're supposed to do. So it will do something, but it probably won't do what you want it to do.
So we will eventually have to handle it for more arguments. The things that I'm working with right now don't have that many arguments, so we can get the easy case out of the way to make sure we're doing it right. Okay, yeah, I keep forgetting to open up YouTube checks and switching windows, and it doesn't have a pop-up right now. Okay, let me try that better. So, how do we want to do this?
Well, you basically have to implement the algorithm.
Right, but that's what I'm thinking. How do I want to implement the algorithm? Do I... Because I could just do it in line. I could say, look for this, and then as soon as I do this, I implement it in line. But then for the call site, I'd have to do a very similar inline thing. So would I instead want to turn this into like a description of the transformation that needs to happen so I can walk through the same description pre-computed for each call site?
The simple thing would just be to just recalculate it every time.
Yeah. I mean, recalculating it every time is fine if it's the same code. I don't want to duplicate the code for an algorithm
It
like
should be the
this.
same code because it's the same
Yes.
transformation.
Right.
The only thing you have to do on the call side that's extra is you'll actually have to convert the things.
Exactly. Which is my point. I don't know how I want to structure this to share code between the two of these.
Well, the classification is going to be the same, so we could factor that out.
Right. Which is why I'm thinking maybe I just turn this into a give me a classification structure that I can iterate through, but I don't know what that would look like. And I probably won't know what it looks like until I start it. So I guess let's just attempt a transformation on F and see what kind of code we end up with. So let's go through every declaration in the module. Equals 0 believe it or not, but having big font like this does make me significantly worse for some reason. But I'm trying to do it for YouTube. I need array count of module declarations. We don't have an array count because my API changes, so we actually want count is module function get count here module I is less than count I plus plus. Boom, we have a function. So let's static void, probably just a void, and say Laye C ABI. And we'll change the name as we get more knowledge about what the hell it's doing. But we want a Laye C value function. We call it the type value all the time. This is what we want to do. Laye C ABI form module and Laye C module function at index module I. So now we have this, and for shits and giggles, we'll put it at the bottom. The entry point can stay at the top. So we have a function. I don't have a way to
I don't think you need
module
to
it.
set the module is null because you already do that when you
I do
pass
that
it
up
in.
here, yeah. I don't want to like accidentally change a variable or something. I usually do it anyway, just to make sure that my calling code is correct. Okay, so we want to go through, for right now, we only care about parameters. So let's param index is YC parameter count. Yeah, I know my lines are twice as long as everybody's lines.
Jesus Christ.
Okay. Yeah. Everybody knows what a for does. This for is the exact same for as the other 2,000 times it's used. I don't mind if it's longer because you know what a for is. So we want to know the type of a parameter, and we want to know a few things about it. So type, param type is going to be LC function parameter at index function param index. It's going to return to me value because it does have a thing. So we'll just say value for param. See type param type is see value. Get type param. My data is all valid, nice and solid. So the ones that we care about now are structure types. So do I have a type is
Yeah,
struct?
essentially, because if you have 2 integer arguments, those will just get passed in separate registers.
Right. So we're going to start with structures and work our way up from there. So param type. If it's a structure type, then the next thing we can check is if its size is less than or equal to 64. And if it is, there's a couple of other things that matter, right? So if it's less than 64, it's going to be upcasted to 64 anyway. If everything within it is of integer or float class, it stays integer class and gets passed in one integer register. So we just pack it and load it as is, right?
Well, let me see. Where's the thing?
I believe that is the case.
Mm.
Right, so these are integer. And if they're all floats, it goes to SSE instead. But if they're hybrid, so this part. So we could go through and provide ourselves a little enum for each of these classes and
Yeah, you probably want one for that.
implement each of these transformations in some fashion here. So let's say type def enum C ABI class. C ABI integer SSE up memory. What other ones are actually relevant to us right now? None of these, no class can be default. And yeah, so if we're ignoring long double and complex long double, then that's all we need, right?
No class integer SSE up. SSE up is just for for if you have something longer than a double, bigger than a double. Yep.
Alrighty. So those are our classes. So we could go through and let's make a quick little function. Static class YC type get CABI class YC type, and then this can get like a aggregate type of things as well. So if we get a struct, we can aggregate the things based on those rules as well.
Yeah, well,
Maybe. Because eventually it's going to have to be broken up by 8 bytes. So this doesn't work 100%, but it might be a good starting point.
yeah, you have to break the struct, at least conceptually, into 8-byte chunks and then classify each of those chunks separately.
So for trivial cases where we don't have to do that, it returns one value. I would like to not return a dynamic array, but I might have to return a dynamic array if we have this handle the same cases.
Well, the things, they do get merged. So if you have an int and a float inside of a single 8-byte, they get merged to integer. So
Right, but
the
if it's
class would
4
be
8 bytes, am I returning 4 classes?
Well, I would call it 4 times for each 8-byte, but sure, that also works.
Okay.
Like however you want to do it.
So, because I'd rather also call it 4 times for each 8 byte, which means we should have an index for which 8 byte we're talking about also come in. So that we can call it and no. Unless you're talking about...
I would argue it might make more sense to just iterate over the fields and then keep track of whether you've exceeded a single 8-byte or not. Because the way this works is you're never going to split unless it's an array, but you're never going to split a field across 8 bytes. Like you never end up with a situation where you have an I16 that needs to be split across the 64-bit boundary because of alignment. And if you have unaligned fields, it's passed in memory anyway.
Right. So I can do this one as a trivial case that's meant for handling less than 8 bytes. And I have a more complex case which iterates through those and handles those cases. Or I can merge them together somehow. That's just basically what I'm figuring out here is what do I want this
The only
to
thing that
actually
I'm
do.
saying is that it's not trivial to just split an arbitrary complex struct into 8-byte chunks.
Right, which I'm agreeing with, which is why I'm thinking maybe this should not do that. And we can just return like an invalid instead of a no class to say, hey, yo, that doesn't work, do more special cases. Or we can just not handle it at all and expect the caller to. I just want a more well-defined idea for what I'm writing. But we can handle some of the easy cases first and see where that gets us. So if YSU type is integer, if it's just an integer, then it's most likely an integer type, unless it's that one case of integers. Was there a case of integers where they turn into memories? If they're like really
Not
big?
memory specific. Well, eventually, indirectly, yes,
Yeah,
because if it's bigger than 64 bits, it gets treated as it. First of all, the size of the int gets rounded up to a multiple of 64.
mm-hmm.
So an I87 would be treated as an I128, for instance. And then that is also treated as though it were a struct of I64s. So if that gets bigger than 8 bytes, it will be passed in memory.
So as an aggregate, they can be. Past a certain size, they will be. For now, I'm just going to, let's do two things. In 64, the bit width. We can do easy bit calculations. So now you see size in bits for type. And I'm just going to temporarily assert that our bit width is small because I don't want to deal with it for right now, and I want to explicitly define that I'm not dealing with it. So we could say less than 128, or I could say less than 256, or I could just say less than 64. And this is still me trying to define the scope of this temporarily. So this wouldn't work for large struct types, I know.
Well, this also wouldn't work for 128
Bit integers.
That's two arguments then, not one typically.
Right. So 64 for now, and we'll handle the
I'm
extra
not sure this
cases.
function makes sense on its own here.
Right. But I'm just trying to figure out what does make sense, because I don't know.
I would just do that in the loop and then maybe outline things if it starts repeating itself.
Okay. So in the parameter loop.
And maybe not handle struct as the first case.
Well, yeah, but it's the first one I'm thinking about. Integer. First case is integer. Should okay. So if we have an integer, I'm gonna catch the bit width for the entire thing so we can work with that. Bit width. I see size in bits. A param type is this. Sorry, the bit width is greater or equal to 0. It should never be negative.
And also in the function, you need to keep track how many integer registers you've already assigned, because we're going to need that at the moment.
Okay. Int registers used 0. And eventually for float registers as well. Float registers used. Okay. So we need, again, for right now, an integer type. We're not explicitly supporting anything over 64. So for this one, I will say bit width is less or equal to 64. Unless we want to go ahead and implement it anyway.
We can come back to this later. Let's say it's 64, but it isn't smaller for now.
Okay, so the easy case is this is just class integer straight up. It's going to get a register, and we move on. So
if there's a register left, otherwise it has to be passed to memory.
If int registers used, we need some classification for how many registers there are. 6. Which I'm going to make a constant for now to indicate that I might need it to change for different architectures.
Well, for a different architecture, you have to throw out the entire algorithm.
That's true.
So
I'm still going to make it a constant so I know what
it is.
it is.
Make it a constant just to avoid magic numbers, but this code is not going to be reusable for anything.
So I'll just
not even for Windows, because Windows also works differently.
I'm going to call it int reg. Straight up 6. 6. And float reg is 8. float reg. Okay, if this is greater than int reg count,
Greater than or
then
equal, because that's the ones you've already assigned.
true.
Use the 6, we can't assign another one.
So in this case, we want it to be memory.
Mm-hmm.
In this case, it's an integer. So if it's memory,
Yeah, and then what you can probably do here is sort of combine the steps, because if you have a parameter that's an integer parameter, and you've already used all the registers, then you're done with that one. You know that one always goes in memory anyway, so you can just do the conversion here instead of having to. Meaning you can sort of mix the steps. I think it's just for structs where you have to sort of compute the class properly.
I understand the last part. I didn't understand the first part you said, combining these two steps.
Doesn't matter. Just keep going.
Okay, so I mean, we don't have to do anything though, basically.
Well, what you'll have to do for integers is you'll have to actually those will be passed in memory. So actually, yeah, LVM will do that. That's true.
Right.
Sure.
At the IR level, these are identical.
Sure.
We just need to keep
Sure,
track.
these should be identical at the IR level, actually. Yeah, I think so.
Okay, so that's good.
I should hope that it just does that. Let me see.
I don't know how to explicitly pass something on the stack anyway, unless you're passing a pointer.
Yeah, no, you just pass them. I was just confused for a second because this is very weird because this is a very low-level thing,
Yeah.
but we don't actually have to implement the low-level details.
Yeah, just the high-level details around the low-level thing.
Yeah, so that is fine.
So greater than F64 is not currently supported for floats.
You don't even really need that if statement in that case. You just need to. Well, actually, no, because of registers used. But then again, it doesn't really matter if the registers used value gets greater than 6. You just have to detect if they've already been used.
Yeah, I'm just writing it like this for self-documentation purposes, so I can leave these comments in the correct place for my sake. They'll get optimized out 100%.
Obviously, yeah.
Everything here is very simple. Okay, so integers and floats, easy. I'm going to go ahead and throw in else if struct. So that I have that type is struct, param type.
Yeah, so this one we have to break up, basically, into fields.
This one we have to be able to break up. We need break up structs into 8. So we can just calculate the number of 8 bytes that would be required and try to figure out where those boundaries are.
I would just start merging and looking up the fields and just keep track of how many fields we've processed, like what offset we're at.
Okay, so in 64.
Well, first thing you can actually do, if it's larger than 8 bytes, just pass it to memory and we're done. Well, not we're done, you'll have to rewrite it to be passed as a pointer, but yes.
Right. So just if it's larger than 64 bytes, right?
If it's larger than 8 times...
8 bytes. 8 times 64.
8 times 8 bytes, however much
8
that
times
is.
So 64 bytes, yeah. So if bit width is greater than or equal to fucking 64 times 64. A struct that is more than 8 bytes just goes in memory. And we can assert for stuff else. Okay. Then field count, IC type struct, field count, member count, param type, index, count. Do you know how to code in C#? Yes, it's my day job. I don't know how long that's been there. Sorry, I've been focused. I've been programming in C# for 2013, 2014 at least, about 10 years, and it's my day job for financial. Yeah, I do a lot of C#. It is one of my favorite languages, despite all of its flaws. And there are many. Okay, so then I believe fields don't have names. I just get a type. So I see type struct member at index param type field index. Would help if I named the thing. Okay. And then because I'm always pedantic and afraid of things, that doesn't matter actually, because the loop is not going to happen. That's fine. Okay, so we now have a type. We can do similar classifications on the types here, which is why I wanted to kind of factor this out to not just do if nested. But let's say int64 field bit width, so we at least know what we're dealing with here. Let's see type bit width or field type. Zero width fields do exist somewhere. Not really here, but they do exist somewhere. Okay. So refresh brain on struct things. Classification of things. Each field of an object is classified recursively, so that always two fields are considered. Resulting class is calculated according to the classes of the fields in the apron. So we just need to start aggregating class information somehow until we hit 64 bits.
Yeah.
So int64t current bit count. And also ABI, C ABI class. Current class is no class. No class. So, and then again, this would just be like a copy pasta of this, which I don't like. And it's recursive. So if I have a struct, I have to do this again. So I do want to put this in a function somewhere.
Perhaps.
He's being cryptic. Perhaps. Perhaps.
I have no idea how to best do this either. The Clang implementation is 1,000 lines of code, so
Yeah.
that's...
Only 1,000. We're...
Oh, let's see. I think the main function is like, let's see. This is so XA664 ABI info classify is about 400. But I think there's a bit more. Yeah, the merging is separate. Yeah, that's just for calculating the classes. Yeah.
Yeah. Fuck it. Figure it out in a second. We're going to start with classify. So, care about this. We need a param type. We need to know about the number of integer registers used eventually, but maybe not in classify. But maybe because classifying it does need to know register info. So maybe we have a classification state. That way we can recursively do this and it's still like a loop. Something like which has these two things in it. Right. So then I can do this. Then so then we have like state, and then we can do classify here on this thing. Right. Classify needs to return a class. So this would and return a class C ABI integer memory. I don't know what we're going to do with it yet, but memory. This is not integer anyway, it's float, SSE, state float register is used. Okay, so then in here we have C ABI class. Field class is this. So then we can do a combine on classes here, which we can do in line for now. If whatever's going on in here. So this is the combination plus this, but SSE is used if these fail, and we're not using these right now. So if both classes are equal, the resulting class doesn't change. So if current class is equal to field class nothing, then if either class is no class, it's the other. So if current class is equal to no class, then we should assert maybe that no, because at this point it's fine. Then current class is field class. Else if field class is equal to no class, then current class is being used, nothing. So that handles that case. If one is memory, the other is memory. Else if current class is equal to C ABI memory.
Well,
nothing.
if the current class was already memory, then that entire 8-byte goes in memory anyway. So
Right. So nothing changes.
maybe even the entire aggregate. Let's see.
But then if this is memory, comes memory. I'm just doing it very explicitly step by step here.
Yeah, because if one of the classes is memory, the whole argument is passed in memory.
Okay.
So if any struct field is in memory, the entire struct is in memory, I presume. But that's technically in the post-merger cleanup part of the algorithm, so
I need to be right back. I'm gonna get some water and other.
I see.
Let me
Sure.
change the text on this. Not reading. How do I change the text? There is click, double click, properties, DRG, and transform to center. Center to screen. Boom. Beautiful.
Sure. Oh, that's interesting. The Bureau back screen uses the Magic the Gathering font, I believe. What's that called again? It's called Beleren. Okay, that makes sense. Yeah, that's definitely the Magic the Gathering font.
And we will
No, you're back.
and we will put the headphones back on. And we can hear everybody. Alrighty. And we can transition back.
The font you're using for your back screen is the magic font, isn't it?
It is Bellerin.
Mm-hmm.
I had it installed. It is the first alphabetically, and I said, fuck it, that looks good.
Sure.
Alrighty then, where the hell did we leave off with my arbitrary classification of things here? Just to get them in code. If one of them is memory, both are memory. One of them is integer, both is integer. Otherwise, SSE, because we're skipping the other one. So we want
Yeah, all the other ones are also just memory, by the way.
I'm sorry?
All the other ones are also just passed in memory.
That's true. That's true, that's true. So if it's int this, and if this is this one to that, matters. If current class is this, then
Perhaps it would be a
that's what I
bit more
mean.
legible if you wrote if current class is integer or field class is integer, then current class is integer.
That would be more readable, yeah. It doesn't really affect anything.
Mhm. The same thing for memory.
Okay, and if they're both no class, then they just stay no class. That's fine.
Well, actually, in that case, yes, it's careful. It's the one that isn't no class. So
Yes. So in this case,
sure, yeah.
that's fine. If this is no class, nothing happens. If they're the same, nothing happens. For now, I'll leave those. That's
I think if you just end up with no class at the end of this, then I don't think you need to pass that because it's either padding or something that's empty. I think.
yeah, I think so as well. If they're the same, if either is no class, that's whichever isn't. That's the whichever isn't is the part that I'm just communicating here.
Yeah. Sure.
We'll look at it again in a second. So the last case was SSE if it's not integer. So else field class is C ABI SSE. Like that. Okay. So that's that. We have classified the thing. And we also should probably know if this is the start of the current class or not by incrementing by bit count sometime soon. Field type bit width. So at the end of this, or even at the beginning, honestly, because we can check field type bit. We can just check here if current bit count is something is greater than 64, greater than our 8 byte, then we want to reset everything and do something
Well,
else.
so something is if the field is also struct, so you have to be careful about that.
If the field is another struct.
Let's see, how does this sound?
Because it can't go over either.
Let's see.
If I did that, then that would be, hey, you're missing padding or something. Here's my. Oh, okay. Well, that's annoying. That's fine. I guess we also have to check if it contains unaligned fields, which for now is not possible.
So yeah. Yeah, if it's unaligned, it's just a memory because you can't really split that. You'd have to split it across registers otherwise, which is a bit too janky.
So I don't have a way to assert that that's the case now. Currently, there's no way to not have unaligned fields. The only option is aligned fields in Laye until I introduce other things. So we're just going to say to do as soon as you can introduce unaligned fields in my structs. This needs to be able to handle them. Unaligned data makes it memory. Whole thing. Okay. Each size of the aggregate, if the size of the aggregate exceeds a single 8-byte, each is classified separately. If the 8-byte, each okay. So if by the end of the loop we haven't exceeded an 8-byte, we just return current class as the classification. Otherwise, we have no way of returning multiple classes. So yeah.
Here we go.
Let's just start with that. Parent it count is less equal 64. Single 8-byte or single, yeah, one 8-byte. 64 bits. So then this would push it over an 8-byte. This would
So what Lang is doing is for structs, it always keeps, when it classifies, it keeps track of both a low half and a high half because it does the merging that way. And for structs, the low half is initialized to no class. Then it goes over all the fields. What the hell is it in here? That's bit fields, we don't care about that. It then classifies the field and merges the low and high values of the field into the low and high values of the struct itself. Interesting.
So it just does it like a binary search? Is that what I'm hearing?
Well, I don't think
Not
binary
search,
search is
but
current here. So
no, but if it's splitting everything into low and high and then moving up, it's at least a binary operation.
well, it may be easier just to point you towards the code than to try and explain it.
Yeah, probably.
If you want to take a look at it, it's in, well, if you pull up the LVM repository, or if you have the source code locally, that also works.
I do have the source code of LLVM locally. I think every time I open it up in something like VS Code, it ruins my CPU, but we'll find out.
I'd imagine.
Yeah, because it's just gonna start doing all sorts of goddamn shit. So what file am I looking for?
In Clang,
Yeah.
Clang lib something. It's Clang lib codegen targets x86.cpp.
Oh, I doesn't want to find. There it is. Code and targets.
Well, codegen is spelled with a capital C and a capital G, so
It should be completely. It doesn't matter. But targets. Like
Cogen, no, it's Cogen is the directory slash targets, I think, or targets, and then x86.cpp is the file name.
Okay.
And it's just search for classify. It's online, and what I have locally, it's 1777. Yeah, that one. That's the that classifies a single argument, or it's over structs. It calls it recursively. There's always some jank like this in here for weird cases. So
class, low class, and high class. That's what you were talking about there.
yeah,
Offset base is low and
that's
high.
probably used for structs, I'd imagine.
Right.
Because I think if the main function that calls this whenever an argument is classified just passes in 0 for this. Yeah, classify argument type just default constructs low and high and passes in 0 for the offset.
It sounds also like SSE up stuff. Because the least significant is SSE and the higher significance are SSE up. So the first would be low and all the others would be high. So it might be shared across both of those, but at the very least, that's what it reminds me of there.
So the offset base is, I think that's for structs, if you're inside of a struct.
Right.
Like, you know, which 8-byte you're looking at. Well, because it's always 2.
Hey, there's the merge thing that I just wrote.
This is the merge thing.
Easier to read than what I just wrote. We're going to write our own merge thing. Let me move that off screen so I can reference it more easily. Static class merge low.
When in doubt for things like these, I found that it always helps to look up what Clang is either outputting or how it's doing it, because it does handle a bunch of extra cases that you don't have to care about, but at least it's a somewhat legible implementation of the algorithm. Because at least I find that in the System 5 ABI, the document, it's not particularly well written in terms of how intelligible it is. Like, it's worded confusingly sometimes.
Return memory. Then if assume is equal to C ABI, because they've already done the transformation that makes it more readable, which is what we have to do. Field is equal to C ABI integer, integer, else if field is everything else that we care about, it turns into memory, else return C ABI.
That looks a lot like, yeah.
Not handling x87 at all.
Yeah, the thing about that is those all just turn into memory.
Exactly. Which I will probably handle at some point, just to say that I handle them. But maybe not in this version of the compiler. I want to either do a bit of a refactor or rewrite or port to Laye on a lot of the IR and start treating it like an actual tool as a simpler LLVM. I've been looking at, for example, the cube IR that Soding.
It's the fourth link here. I think.
The hair uses it.
It's already here. It's already on screen. I think it's the third or fourth link.
Intermediate language. Aha. I was just seeing all the other ones. This one here, I think it's ugly as hell. But
I think it's harder to work with an LVM from just reading it, at least.
Yeah, it's a lot less legible. So I would love to be the middle ground between this incredibly simple, hard to read nonsense and the behemoth that is LLVM. That's already kind of what my plan was in the first place, but now that I've seen somebody try to simplify it, I'm just like, that's ugly as shit.
Yeah, you can't read that.
And I would love to just simplify this. So if I could compete, quote unquote, in this space of LLVM but significantly simpler, that's eventually an end goal. I've already got a name for the IR and everything, right? I'm not using it in here because I didn't want it to be the final API, but it will be called Liar. That's what it's called in the compiler call here, right? We're emitting Laye.
Inside of LVM, in LVM we do have MLIR, so that is a higher level framework, if you will. But you basically have to use C++ for that because all the tables and stuff uses C++ and so on.
Okay. So we've got a merge, we've got a classify. We're going to alter our classify a little bit. So they are doing what I said, which is they are taking an offset. They are taking a reference to low and high for reasons. We're going to do a class low and a class high.
Those are just default constructed and passed in by the caller. But in this case, it's for structs. So for structs, you can pass it in recursively. That's also what the offset is. That's also initially 0 if you're at the start of a struct.
And then I don't know what we're going to need is named arg or anything else for. So for now, until we get there,
Don't think so, no.
until we get there, that's all we need. And the state might not be necessary anymore.
The state is just the parameters in this case, yeah.
Yeah. I mean, the state currently has the number of registers used.
Oh, yeah,
But this can be handled at the call site instead, now that we're simplifying the way classify is being called.
Yeah.
So it can say, hey, if it gave me a register, if it gave me an integer, but I'm out of registers, I'll transform it into memory.
Yeah, that's called by the caller. That's only used by the caller of classify, at least in Clang.
Right. So I don't think we need that anymore. So this whole thing can just return integer and not increase the number of integers used. Whenever we return an integer class, we then increment the integer register.
Yeah, I
So
think splitting that up a bit makes sense.
C ABI integer and C ABI SSE like that. So that simplifies that.
You can also just, I mean, that's maybe a matter of style, but you no longer really have to write else if you're returning.
That's true, yeah.
That way it's less nesting.
I'm not afraid of nesting, but it is getting kind of out of hand. I think sema gets really bad. That's a brief aside. Sema is absolutely terrible for nesting. Like some of this is nonsense.
Yeah, it does. Let me see what my well, actually, let me take a look at both Clang Sema and Source as well, because let's see. Let's take a look at this one here. LVM uses 2 space indent, so it's
Not
less
as bad.
convoluted, and it also just likes to break out functions if they get too long. So some of the functions do get long.
Yeah, I'm no stranger to long functions. My analyze function here is probably a good long, many hundred long.
Yeah, we have what's that? 1, 2, 3, 4. Yeah, 4 to 5 levels of nesting in here.
My current analyze node function in Sema is about 1,200, 1,300 lines for one function.
Mine is also like 1,500 or something. Let me see how big is mine.
So
because I've broken some of the stuff out into smaller functions, but let me see. So this is. Let me see. No, not just for procedures. That is for invoke. That's for casts. That's names. That's types. Yeah. So it's whatever 3,600 minus 1,900 is.
Well, may as well just be off
1,700
so 1,700
apparently.
Yep,
1,700.
a little longer than mine. And you've got all the fancy saving on syntax. Mine is just half boilerplate C. Okay. So
well, Clang is a lot worse in that regard because a lot of the Sema files are like 20,000 lines of code, so recompiling them takes half a minute. It's really annoying if you change one line and you have to recompile sema decal cxx.cpp.
Yeah. For reference for anybody else, mine doesn't take that long. It's broken right now, but boom, it's recompiled. So easy. Okay, so I'm adding some other classes while we're here. Void becomes no class. We don't have a special case for int28 just yet. We could. I mean, if it's a low and a high, I could do that. I could say if it's exactly. So I wouldn't mind supporting exactly 128.
Well, the thing is, if it's less than 128, it gets rounded up to 128 because it's rounded up to the nearest multiple of 64. So
Right.
this even works for less than or equal to 128.
Okay, so let's make it 128 here, and I'll handle this at least 128 case. So if it's just returning current, right? So let me.
Also, currently, it's a bit confusing because you're both returning and passing in low and high parameters because Clan's function just returns void and sets low
That's
or
true.
high.
That's true.
Oh.
And notably, it also sets current, which is either low or high.
Yeah, well, current is only used in this function.
Yes, got.
But yeah.
So yeah, we can turn this into void because I do like what they're doing. So then we want to say Laye C ABI class current equals either low or high if offset base is less than 64, then low high, and then current equals at this point. Make sure they didn't give us null for whatever we're using.
Oh, that way you only have to check only one assertion for both. That's cute.
Yeah, sometimes it's nice, isn't it? We want fucking memory. This one, brain. Couldn't think of C ABI for some reason. So there's our default case.
It initialized it to no class, but sure. Oh no, it
did
does
not.
set both to no class and then current to memory. Interesting.
That's what it does.
Sure.
So then I do have to search that they're not both
Oh
null.
god, I'm not sure these assertions are necessary, but sure.
They're not necessary, but I'm a fallible programmer who could call this function fallibly. So
that's true because in C++ we're passing in references, so that risk is a non-problem here.
Ain't got that. Laye will. I won't need these asserts in Laye. Low is C ABI no class. High is C ABI. Then current. Current now is never going to be null. We don't need to assert that. Current is now just memory. Okay, so that does that. We are now up to date. So then current is this. Now it's not a return anymore. I do want my else ifs back.
Well, you can put a return after you set current.
Does it do anything after?
Well, I don't think it needs to do anything after.
I don't know.
Does it?
There is a return at the end. I didn't read that far down. So if it's a built-in type, we do the thing and we return. So we can reintroduce the return.
Mm-hmm.
So then this is current. It is return. That return equals return. That's a 4. Okay. So then, not doing, if it's greater than or equal to bool or less than or equal to long, that's integer. Yep, that's our integer check here.
Yeah.
If it's explicitly a 128, then it does low and high. So
yeah, because that first big if is only for built-in types, and like an I17 would be something else, or a bit in 17 in this case, I guess.
Yeah. So that means that I will have an additional case here for non-built-in as far as Clang and C are concerned, but for Laye, they are built in.
Mm-hmm.
Else if. So what I'll do is else if bit width is less equal to 64, and that covers the rest of the built-in cases for C.
Sure, yeah. You probably want greater than 64 and not equals to 128, though. And you probably just write
do them in a different order here. This is what I'll do.
It's like,
if it's less than or equal to 64, it's 1 integer. If it's less than or equal to 128, it's 2. Otherwise, it's a bigger one. Otherwise, it's equivalent to a struct, but it's still classified as an integer in the IR, so we'll do something special for it.
Yeah, just that's unreachable currently, so.
which is here, unreachable.
I don't think you need to write due to previous assert, but okay.
But I'm stupid. I write these for myself, not for the compiler. I know how I program and I know how I read code, and I am stupid more often than not. These are compile time checked comments. Asserts are beautiful. Assert more than you think you need to, because at least if you're wrong, you'll know about it.
Yeah, we have, as you can probably see at this point, we do have a bunch of assertions in LVM as well, and LVM unreachable for the rest of them.
And for those who don't know what Laye is, and like not following along my ramblings, we do have assert in the Laye language now as well. It's one of the first things I did as soon as we got the basics out of the way. I love assert. Assert
I also have basic assert as well as static assert with basically the same syntax as you.
I like that it's explicitly not a function, just for all the reasons I laid out before. But it's you get more language control over it. It looks like a return, or like, I mean, if and while and for are all exceptions to the rule in that they've got this, but like your return or your break or your whatever don't. So I prefer this if I can.
And in my case, it has to be a language feature because it also affects how type checking works. For instance, if you assert that an optional is not nil, then in the rest of the code, the compiler will actually allow you to convert it to the underlying type.
You could do that at the language level. C# does that at the language level. Asserts and things like that allow you to check the nullability of a thing at like user space level.
Sure.
It's just more work.
TypeScript does that too to some extent.
Yeah, in C#.
But it's easier to just, if you have it as a built-in language feature rather than just having to match on functions.
Yeah, in C# you can do like dictionary dot try get value out, for example, whatever, out var this thing. And this functionality lets you know if this returns true, this can't be null if the type is not null. And if it returns false, well, then it could be null because it's unassigned. That exact same language feature with a slightly different annotation also lets you do debug assert who is not equal to null or is not null to be like modern, right? And then that same language feature allows you to check this pattern expression at like it's different language features, but it's the same underlying concept of annotate the parameter and influence the compiler's decision moving forward. But that's a lot of work to implement. So a language level feature like this makes it even better. Because I'm going to be doing the same things.
It's more annoying even if you have to also track struct fields and stuff like that.
Yeah. Anyway, so another reason that I forgot to include because I forgot about it, but we're going to be doing patterns eventually for variants and other types, so I'll be using it for the same thing. Anyway, back to our thing here in our ABI. Unreachable code. Void int float. We could also support float 128. We could skip 80. 80 is the one we don't like. 128 is fine, right?
Question mark? Float 128. I'm not terribly familiar with how that is used or how that works.
I don't know, but it's SSE and SSE up. And we're supporting SSE.
Apparently it's doing that, so sure.
So long as we don't touch our fucking x87s, I think we're fine. So let me go make sure I've got SSE up here. I do. So
I don't think I've ever used float 128 for anything, candidly, or long double for that matter. So I don't use floats generally. Like the only things I ever use floats for is like timing stuff or stuff like that.
Yeah, but I want to be writing games and shit. So our example here of toting ball relies heavily on vector 2 with float values. Not 128s, of course, but also I really need to introduce constructors. God damn it. Look at this.
Yeah, some syntax for that. It's very annoying not to have that.
It should just be equals color thing with the numbers 20, 20, 20, 255. And we talked about potentially just having var as well if we have if you don't want to explicitly do it here, because you can't just do this. Sadly, I've designed the language such that this is not good. Because
that's what I'm using parentheses for that.
Yeah,
braces.
but I prefer this for structured construction because it's not a function call. So
Yeah, in my language, it's more like a function call.
yeah, and so I'm resigning myself to adding a silly keyword here to do reverse inference basically on the type here, because for everybody who doesn't know, this is an expression. You can just do this. So I could say yield the address of ball velocity, and then you could dereference that and assign to it, and you could do dot this fucking dot x equals 10, right? Like all of this nonsense is a valid expression in Laye. And since I did that, that means I need to have some signifier before it if I want to use the same syntax for.
An alternative would be is what may be coming to C++ at some point, because it's a feature called do expressions, where it's basically a compound statement but with do in front of it, and that makes it an expression.
Which I might do, but
that would be that way you could invert that if that's what you prefer.
Correct. This would be used far more frequently, so I might do that. The reason I haven't yet is one, if I do this, then you're expecting while, so I'd need to change the parser slightly to not always expect while. That's easy.
It's also a solution. Instead of do while, you could use the much more fancy repeat until.
Repeat until.
And then that solves that problem.
True. The other problem is, depending on how far I take the monadicness of built-in types, do notation.
Like Haskell?
Like Haskell do notation is still in my brain for maybe I do Haskell do notation. I don't know if I will, and I could call it something else, but also I could key off of, like right now, if I did if foo bar, that's illegal Laye for right now. You have to have braces.
I see.
Only because I'm not sure if I want to use that restricted syntax to allow other things in the future. So I could do the same thing with do. If you have do brace, it's a do expression. If you don't, it's a do Haskell style do block. Yeah. Right? So I could still key off of that if I wanted to. I just haven't committed to that yet.
Might make sense, because the thing is, do if we're saying that do takes whatever comes after it and executes it as an expression, then do with anything that isn't the block would be pretty pointless, because you could just write that expression instead.
Exactly. That would be funny though. Do foo.
Yeah, it's God, it's like fucking Fortran.
That would be such a meme to do though. Even better, my favorite, do Zizzy. Do nothing.
God.
Do nothing.
Well, do actually instead of call, do is literally just intercal. Intercal requires you to start every line with do or please do.
Please. Because then I can do try do. If do is just an empty unary do the thing on the other side, then I can do do. I can program. Yeah, I can program into Rude Sandstorm.
It's like in C where you can write const int, and it's the same thing as const int. Because you can just repeat const any number of times in C.
You can't do that in Laye. I didn't go that far. I kept the left. I have east and west mute.
That's a good thing.
Instead of doing that,
the type syntax for the people who don't know, the type syntax in C is just very wonky. Like you can write long type def extend static long sign const int, and that is valid, and it's a type def. That is, I mean, I'm not sure static is valid with type def actually.
I don't think so, because they're in the same classes, right? It'd be a static or a type def, but not both.
Yeah, type def is a storage class. That's worse. God.
Yep, it is not a type modifier, it's a storage class. I do remember that.
Yeah.
I did inherit this. I think it's funny, so I'm going to inherit east mute and west mute. But you can't mute. That's invalid. You can't mute to mute. That's invalid. You must commit to exactly one of each.
I'm not sure you can do two in C++. Let me see. Can you do const int? Does it let you do that?
Can you do constant const?
Okay, hold on. Let's see. Well, I think it warns about it, but apparently it doesn't have. Yeah, you can do const in const, but that's also in the C grammar apparently, because no one bothered to remove it. Probably for backwards compatibility. I don't know.
So if I just say,
I know they write this for sure. Maybe someone would be insane enough to use a macro instead of a type def, because there's actually one case where you have to do that, and I think you can't use align as in a type def, if I recall correctly, in either C or C++. So if you want to have a quote-unquote type def that also has align as, and you don't want to make it a struct, you have to make it a mapping, which is absolutely horrible.
Then in the case of this, its low is SSE and high is SSE up.
Mm-hmm.
And then here we do the exact same thing, unreachable due to previous assert, because 80 is the only one not supported. Everything else should be less than 64 or 128. Boom. So if we decide, there we go.
You could even check for 64, 32, and 16
Explicitly.
because if someone passes in an F48 or something, then I don't think
Which, again,
there's
shouldn't be allowed.
that knows how to do that. Yeah.
Yeah, which syntactically F42 is an identifier.
Yeah, that makes sense because it's nonsense.
I'm tempted to include it just for memes and then just be like, what are you trying to do, and throw a compiler error, but that's less useful than just allowing them all as identifiers, because you might have F and F2.
Error. Seriously?
I mean, like, you might have a float F. I mean, I'm removing the float keyword probably, so you might have F32F and then F32F2. I don't want that to be an error. That's silly.
Yeah, sure. That makes sense.
So, for the time being, it should be impossible. But that's what asserts are for. So, if it's equal to 16, you've made my code more verbose now. You've activated my trap card.
46. Oh no, not an F46.
F46, my favorite. I can't wait to actually explicitly support arbitrary integer types, because I really want to be using U27, like, very badly. U27 is the one I'm looking forward to.
But what are you using a U27 for?
Unicode. It's a Unicode code point.
Oh god. I see how it is.
Because Zig does that too. Zig U27 or something.
It does. Yeah, sure. Because it's technically sure. Oh god.
Zig Unicode. Oh. Maybe it's an I27, but I assume it's a U27. Somewhere in here they use U21. That's what it is. Not 27. U21. A U21 is a Unicode code point in Zig.
I'm just gonna call that one char and make it 32-bit or something.
I mean,
maybe.
it's gonna round up to 32. It's just got the semantics of a 21-bit integer.
Unless you make like a packed type or something, then I'm not sure what will happen. Honestly,
neither am I. For ASCII only text processing or U21 and handle Unicode code points. There you go. Yep. Anyway, so this is. I am 50-50 on if this is even a good idea, but I think it's funny, so I'm just gonna do it. And that's all that matters. It's my language. I'm not gonna be building NASA rockets with it. And even if you are, you don't need a Unicode code point, so it's fine. U21. Funny shit. So unreachable there. We've handled float. We're not doing long double or long float. Long double float. Long double, yeah, floats. Well, that's fine.
It's only sort of related to that, but one thing I would recommend is if you do want to have both signed and unsigned integers in your language as types, is implement safe integer comparisons. So if you're comparing a signed to an unsigned, it should a signed integer that's negative should always compare less to than an unsigned integer.
Oh,
stuff like that.
Interesting.
C++ has functions for that. It's like standard compare less does that. That at least makes these sorts of numbers somewhat more bearable, because the problem is that I have, and that a lot of people have nowadays with unsigned integers in general, is that they're fine until you start mixing them with signed integers.
Yeah.
If you use either one in isolation, there's never a problem. But as soon as you start mixing them, problems just appear.
Right.
Because now you have to either insert casts everywhere, or just or it's horribly unsafe or whatever. So they're very annoying to use together typically.
Oh yeah, and that's why you'll see me use int 120 or int 64 explicitly everywhere in C at this point.
Yeah.
All of my sizes, my offsets, my everything are that. And if I go into like LCA mem, There's a lot of casts to size t for explicitly that
Yeah.
reason or a couple to interact with needing to do unsized stuff for libc's malloc and stuff, and there's probably way more of the opposite in 64 to go the other direction. I guess not in this file. There's lots of places where I have to interact with size t though, and I just don't.
Yeah, my solution to this problem is not supporting unsigned integer types, just unsigned operations.
Pulling a Java.
Sort of, yeah. Java actually does that. It's
It
interesting.
does exactly that. Yep.
It does do that.
Which I don't hate, actually. I'm currently supporting them just because, but there's no real reason to. Yeah, except for unsigned operations. What are your unsigned operations look like? Are they just like a fancy operator? Do you have a function for them?
They are operators, obviously, because making them functions would be horrid. So for shifting, the only thing that matters is right shift, because left shift is the same for both.
Yep.
So I'm using the triple right.
Doing the Java, yeah.
Because that's like the established symbol for that at this point.
Mm-hmm.
For comparisons, I actually thought about this recently, but I forgot what I arrived at as a conclusion. Let me see if I wrote that down somewhere. For comparison operators, I think I was maybe going to use like star greater or star less than or something like that.
I am leaning towards either bang less or less bang.
Yeah, okay. That's an option.
If I were to do that, because I'm thinking it might be similar in purpose to floatings ordered and unordered. But I don't know if I'd want to overlap a floating unordered comparison operator with an unsigned and signed unordered, or like ordered rather, comparison operator. Because this is ordered less for floats, and this could be unordered less. Well, unordered less would be not greater, right? That's why I have it for floats in my mind, because the way that I have seen the operators done sometimes, I think it was at one point D did it this way? Question mark?
I don't remember.
But for unordered stuff, they said it was not the opposite operator. So not greater would be unordered less, I think. So not greater equal rather would be unordered less. Sorry.
No. Colon greater than is what I arrived at apparently, and less than colon.
Oh, so you did this and wait, did you just say you did this and this, or did you say you did this?
No, that's the second one.
Okay. Interesting. They're little faces. I mean, they're little faces here, regardless, happy and sad.
It's weird if the colon is just always on the right, always on the left.
Yeah.
I feel like it should point in a direction.
Interesting.
Mm-hmm.
Things to think about.
Comparisons, and the only thing that's left is division. For that, I might probably just use double slash and double percent. Because comments are triple slash in my language, because I always use that. So.
Also, double slash is an operator for you.
Double slash is probably going to be an operator because I can't think of anything better.
Right. If I were to do double slash, I would make it a flooring integer division for floats. So 1.2 over like 2.3 is a float, but double over is a floored int.
Yeah, sure.
I don't know if that's a good idea, but it's a funny. I would definitely do that in a dynamic language like Lua or Python or something, because the type would probably not change. It wouldn't become an integer. It would just include a floor operation. We're getting so sidetracked. I wanted to.
My bad, I guess.
Oh, hey, me as well.
Oh, and I'm also planning to do the Rust thing, where at least in debug mode, integer overflow is an error, and there will be separate operators for wrapping addition and also saturating addition, because that's useful sometimes.
Ooh, actually, yeah, I was thinking about doing wrapping operators as well, because then you can explicitly bypass undefined behavior on those kinds of things if you still wanted to support undefined behavior for optimization reasons. And for that, I was definitely thinking, like, I think Zig does plus mod, but I was thinking the same thing. That's kind of an obvious operator.
I also have plus mod written down for wrapping addition and plus vertical bar for saturating addition because it's kind of up to a ceiling. That makes sense for me at least.
All right, that makes sense. So saturating addition is like int max plus 1 is still int max.
Yeah.
Okay.
It never goes over. That's like useful for, I don't know if you. There's some application where you need to count up to a maximum and don't want to go over.
There's yeah.
Some, like,
Imagine if you had an operator that was parameterized by a value, so you had plus pipe template argument 10
saturating addition for 10
up to 10. Don't go higher than 10, please. Oh, that would be nuts.
At that point, I'd make it a function.
I mean, yes, but it'd be funny. Consider a new operator
sure.
toast for.
I should do if only I had my more time. I'd do that at some point. Just make a programming language that's not necessarily bad, but just cursed, like a cursed con language. But it's a programming language.
Oh, 100%.
I think they call that an SOlang.
Yeah, I think I've mentioned before, but if we go to SOlang, I have an SOlang implementation somewhere.
I recall you mentioning that at some point.
Brainfuck with closures, which doesn't work as well as you think it does, but also it kind of worked.
I don't think it would work very well, so I'm not sure. Because it's still brainfuck at the end of the day.
It's still brainfuck. Mindfunk. I used a really mindfunk. It was a pretty funny name. Yeah.
Oh god.
Why is this of all pages so slow?
Fascinating.
Mindfunk. I believe this page would do it. Yep, and I was using some shitty weeb alias. Sekai Kyoretsuna. At that time. This is a long time ago. Right, it's the regular brainfuck plus is plus, but we've called things consumers because they consume arguments. To pass arguments to a consumer, we use this as a separator. If the to consumer exists and accept one argument, you could call it like this. Call the to consumer with the argument plus. And you could implement the consumer, or you can compose them with parentheses. That's right. So the default consumer built-ins were the same brainfuck operations here. You declare a new consumer with this syntax, one parentheses to open it, another parentheses to list the args, and then close it with the name. The name, I think, could only be one character, and the body was the sequence of things you wanted to do. So this was the most concise way to do it, but I would write them like this with two space indentation. So if you had a consumer R that took another consumer F, you would run write F, and that would be expanded. It's basically macro expansion. I don't think they were technically closures until we got here. And then I was like, with anonymous, well, there's nothing really to close over. So they were like implemented as closures behind the scenes. And then I realized, wait, I don't have any memory to close over. So then I stopped calling them closures. So then anonymous consumers were the exact same syntax, but you didn't give it a name. And they had this. So you could use this like functional programming inline functions. So instead of R whatever, you could do R of an anonymous consumer, go right to and then plus. So you could write this code to do this stuff. Functional brainfuck. I'm just saying.
Oh no.
It was a really good idea. And I might redo it. I might re-implement mindfunk and update the SOlang page. And we can write it in Laye. Come full circle.
I should do that on April Fools. Just write a compile that compiles, or maybe even that compiles brainfuck. Either JIT compiles brainfuck or compiles it to LVMIR.
Okay, no los dos. Why not have a circular thing? Compile brainfuck to LLVM and vice versa, or something.
LVMIR to brain. Oh god.
Exactly, but then you have to have a the round trip. You need to have a round trip test so you can compile your LLVM to brainfuck and back in the same compiler.
God. I mentioned that before in the Discord, but compiling to brainfuck just means compiling to a Turing machine, basically. So that would be pain. Because if you've ever tried to make a Turing machine that does anything useful, it's pretty painful. There's a reason it's a theoretical model.
Yep, it is not the practical one. I'm still interested to re-implement this because it was so simple. You just, heap allocate a couple of function pointers basically and call them whenever you hit this symbol, and you're done. It's easy. I could even just write this in straight up, like I could compile this to And the interpreter, I'm thinking like three things at once, and I'm trying to tell my brain, stop, focus on one thought, let's go. This would be easy to compile to anything, but it'd also be really easy to interpret, and you could do foreign functions in it because they're just function pointers. So you could also write an interpreter with a default FFI interface that's just use the correct function pointer type def, and you've got foreign function support. You could write this in a couple hundred lines of code, and it would be it'd be a full ass library. It would be a library that you could use. It would have documentation, and it'd still be less than 200 lines of code. Oh, it'd be great. That's an idea. Maybe we do that on stream at some point. I need a list of stream ideas because I keep thinking these things and then not doing them. I have kind of a list.
Stream that on April Fools.
Yes, that's very soon too. It's on a Monday. That's a work day. Unless I get Monday off. I can do it after work though.
Right after Easter, so that's that.
True. I kind of have a to-do list in that sometimes I make a little folder for something like a C compiler written in Laye. I want to do that on stream. Laye build system language. What do you mean by that? Because the Laye build system language is going to be Laye. So what are you implying that we do instead? Mindfunk is the build system language.
The only way to create something that is less legible than CMake.
That would be fun. The shell written in Laye idea. I have a Git in here I want to do. I called knit. So I want to write Git. I want to write a Git, but I want to do it in Laye, so I've been putting it off. That's in there. I don't think most of my ideas are in here anymore because it's a new install. There's my brainfuck compiler I want to do. So maybe that'll turn into a mindfunk compiler as well as an extension. Have a brainfuck compiler driver that knows what variant of brainfuck you're writing.
Oh God.
Would be fun.
That sentence is already horrible enough. A brainfuck compiler driver.
Yeah, that's why I said it. That was great. And yeah, most of my things aren't in here anymore, so that's fine. But yeah, I need to make a list of ideas. We don't need the LLVM one anymore right now. It's getting late enough that I might have to take a break here to go farmers market stuff. Maybe I come back later in the day and finish this up, or maybe I just pester you off stream and stream a little bit later. I don't know. Depends on how the rest of my day and weekend goes. This might be a Sunday thing, and I just ping you. This at least gave me a good understanding, and this document will serve me well. Now that I've got Clang pulled up, I'm going to not copy everything because this is a nightmare, but I can definitely reinterpret enough of this.
Yeah, you probably don't need the code that deals with bit fields a bit further down.
No. I eventually want some sort of bit field implementation, but I don't think I want C's bit field implementation. And I probably won't give a shit about it in the ABI sense. Like, I mean, I want to support as many C features as possible, just so I can import all of the C code possible and still call it. But that doesn't necessarily mean that Laye will be able to do it natively yet. So
what I'm gonna do for bits probably is just have a bit type that is just like an I1, but it's packed. So an array of bits would be packed into bytes.
Right. Yeah, and if I do anything, it'd be very similar, or it would just be yeah. No, because no matter what else I do, it's going to be similar to that, probably. I was going to say, oh, well, it's just going to internally transform it into an I32. Well, that's exactly what you said, just in different words. So, nothing really else to do with a bit field. It's kind of, by definition, what a bit field is. If it's a pointer, it's an integer, that's good. Yep, if it's an enum, it's the underlying type, which is just going to turn into either a single integer or a double integer, most likely, or the memory if it's huge, so that's fair. Dude, imagine having an enum that's of type like I512. Might just want to not support that in the language at all. Your enum type has to be 64-bit or less. I'm sorry, dude.
If I recall correctly, there is a proposal to allow that in C, like enumerators larger than int max t.
Yep.
And I don't know about C++ currently because I don't think anyone's using that. Like enums that are larger than 64 bytes.
It makes sense if you're not doing strict enumeration on them, which a lot of enums don't
Yeah,
anyway.
yeah, as a strong type def, sure.
Yeah.
That's a pretty common use case for enums, but even then you typically don't need things that are larger than 64-bit.
No,
So
I'm imagining you've got like you're reading in a byte code and you have like, oh, these first 2 bytes are this, these next 7 bytes are this, and you've got like a 112 or a 5, like basically the use for bit fields, but not as a struct. Is like the only use case I can see for this. Or if you're doing a lot of flags and for some reason you have which are still just bit fields, right? So like I'm inclined to say in Laye that an enum must be smaller than or equal to 64 bits. But also, I don't want to discourage the jank sometimes. Pointer representation is easy if it's a pointer
member
type.
pointers, you don't have those. You don't have to care about that.
Cool.
Because member pointers are weird because they may include vtable offsets and stuff like that. They're not
Right.
actual pointers. They're like fat pointers sometimes.
Skip fat pointers. I mean, I have slices, but slices are just going to be structs.
Yeah.
Anyway,
Those are just like structs, like
Yeah.
because
the internal
basically,
representation of a slice is just going to be type def. Nice. Fucking. I don't know if I'm going to put the data first or the size first. It doesn't really matter, but it'd just be like whatever type t data aimed off so it can count. And technically, it would be a buffer in Laye. As much as I like this syntax for being something you don't want to type often because I don't want to encourage you to do it, at the moment I have to type it a lot. And I'm not good at it because I got fat fucking fingers and I don't use my pinkies for things very often. I use my pinky occasionally for this and occasionally for like this maybe. But when I go to type this fucking buffer struct, my hand just wants to use the exact same finger for both of those and I just hit them both all the time.
I see.
So it's doing its job. I don't want to use buffers. So I can't complain. I did it for this exact purpose. But I don't have slice support right now. I don't have allocators, so I have to use buffers. I don't have generics fully implemented anywhere yet either, so I can't hide them behind a type def or behind a struct. I'm having to use the feature I designed to not be super fun to use, and punishing myself.
That reminds me, I recently fixed a very annoying bug with how dependence was tracked in lambdas with explicit object parameters. That was just very annoying.
Oh no.
God.
And then I assume these vectors are actual vector types, not the standard vector.
Yeah, these are LLVM vectors.
Yeah, I'm gonna figure out what the fuck I'm gonna do with
The way
that.
you get those is in Clang at least you do attribute vector size on a type def or using declaration. That's how you get these.
I'm tempted to do vectors like hold on. How do I What were you saying while I'm thinking of vector syntax?
Sorry, what?
You were saying something before I brought up vectors.
What was I saying?
I
was
don't
talking
remember
about just a bug I fixed recently with dependence and
Yeah,
template
that
lambdas
one.
and stuff like that. So what syntax are you thinking of for vectors?
I don't know. I was thinking I could reuse this or something because it's already the slice type. But this is an array. So should arrays just be vectors?
That's also a good question because the thing is, it's a bit weird. In there are some differences between arrays and vectors, mainly that vectors are packed, arrays are not. So if you have an array of like I28s, that's
There's
actually just
padding.
going to be an array of I32s. But if it's a vector of I28s, you do have the 28 bits packed together. Now, there's no hardware that supports that, but LLVM will just emit something for it. And the intent is that you only use well-defined vector sizes. So that's the only reason I think why they're not why they're separate. And also, you can't nest vectors; you can nest arrays in LLVM-IR. That's why, for instance, MLIR has tensor types, and the way they're handling that is they're lowering it to nested arrays, but the innermost one is a vector sometimes.
Interesting. I could do that. That looks more like a dictionary type to me.
That looks like a constructor. You're constructing a T. That
Oh
would make
shit,
that
you're right.
even worse.
That is worse. Fuck.
What I'm doing is I'm just doing angle brackets. Like,
Yeah, but this is now a generic type instantiation.
yeah. But the thing is, I only allow vectors of built-in types because it doesn't make sense to have a vector of some
True.
struct
So if
at
you
least.
F32,
Only integers or floats. And at that point, the only thing it can be is a vector. So that's one case where you don't have that ambiguity if you only allow vectors of built-in types.
that's true. That makes
That's my
sense.
solution to this.
I'm then inclined to do a funnier syntax of like this or something.
That's just more verbose, though.
It's more verbose. It's more cursed. It's going to be harder to parse. It's not consistent with the language. 32, a vector of 32. That's interesting. I don't hate that.
Mm-hmm.
It does make it less consistent because you can't just change the type because this means something different now.
Mm-hmm.
But I don't hate it.
Thing is, though, that's I don't currently have that implemented in my compiler. I just use arrays for a lot of stuff instead because I'm still on the fence as to whether you really need dedicated vector types. Because the only thing you need that is if you're doing SSE. But the thing is, what I'm supporting is what's it called again? Array programming, where you can add like two arrays together. And
Oh yeah, I want to do that
element
as well.
addition.
Yeah.
It'll
be in the
those
standard
cases,
library,
I
but-
lower it to LLVM vectors. So I have yet to run into a case where I actually need separate vector types at the language level.
Right. Because my plan for that as well was going to be you could implement it at the language level, and I'll define the interface for it at the language level, but it won't be implemented in the runtime. It'll be a special case for the compiler to implement and remove the call. So I would do like T slice or T array of n, for example, T array of n operator plus however I'm doing template syntax for T, I don't know yet. T I did n as well, I32n or something, right? Tn left, T n right. And then I would just leave it like this, and the compiler would know that a call to this should check if you can transform these into vectors, and if not, it's not technically supported. Otherwise, like, you'd have to go define a specialization for yourself or something, for your specific type. That's what I was thinking so far. I don't know if that's the greatest idea. I could just not define it at all, and if there's no overload found, it defaults to the vector implementation, and that probably makes more sense than forcing one to be defined at the language level.
Allow not overloading it and just always use the built-in interpretation.
Yep.
Because in C++, for instance, you can only overload operators if at least one operand is of enum or class type. Otherwise, it doesn't work.
I'm of the opinion.
Reference to it.
Yeah, I'm of the opinion for Laye that it should be arbitrary types, so long as a binary operator takes two things, and you can do whatever the fuck you want with it. Because I'm not doing like v tables on anything, right? So it's not limited to it being a class.
Overloading addition of an I-27 and an I-28 is not particularly useful.
It's not particularly useful, and I might do warnings or errors for overloading operators that already exist for primitives, but for any other type, like I don't want to say you can't add two arrays together as an operator just because neither are a class.
Also, I will say makes it a bit annoying because now you need to model everything potentially as a function call. You need to do overload resolution for operators on integers, and that's just annoying.
Yep, I mean, that's already kind of the plan anyway, because if you were just to call this add, that's all I want to do is make sure that it works regardless of if it's an operator or a function, and it's exactly the same code for the SEMA to handle. So it shouldn't be terrible. A little bit more work to make it work in both cases correctly, but basically what I want SEMA to do is if it doesn't have a built-in operation for it, just do regular function call, transform it to a function call, do overload resolution regular way. Which is why I think I would say I32 operator plus I32A, I32B. Cases like this would probably be an error, saying, hey, that's already a built-in operator. I'm not going to let you specialize over it for complicated reasons. And that would happen for any two integer types or integer plus float. Like anything that's numeric plus numeric at the built-in level would be an error because please don't.
Number if you support point arithmetic.
If I support which one, I'm sorry?
If you support, I can't talk. If you support pointer arithmetic,
I support pointer arithmetic on buffers, which is the whole purpose of buffer type. So
I
T
see.
buffer, you can do T buffer plus a number, or T buffer or a number plus a T buffer, not a T buffer plus a T buffer. But a pointer is literally, it points to a single thing in memory. You're not allowed to move that point around. So this one does not support arithmetic. This one only supports it plus or minus a number in either order, plus an offset. So yeah, including buffers in that. A buffer plus a buffer, though, you can overload that. I don't know what the fuck you're going to do with that information, but by all means. Because buffers don't have, they're not fat pointers, they don't have a length with them. A slice plus a slice or an array plus an array makes sense. But a buffer plus a buffer? No idea.
Yeah, it's just like a pointer plus a pointer. Pointer minus a pointer makes sense, but a pointer plus a pointer does not.
Right, I should do pointer minus pointer as well. Isn't that... I was watching or reading something recently about offsetting pointers being undefined behavior, but I don't remember what the cases were for it.
Well, if you offset into a different object, sure.
Right.
If you have like two arrays on the stack that just happen to be next to each other, and you offset from one into the other, creating that pointer is not UB, but dereferencing it would be, because you're outside the bounds of an object.
Right, which made me curious because strings, everybody does pointer arithmetic on car star, and a car is the object in that case.
Well, it depends. If you have if you have an array, then the entire array is an object. It's not about what the individual pointer is, but what it points to.
Right, but it doesn't know.
Basically, if you have an array of 10 characters, then
those are
using
guaranteed
a
to be
pointer that
contiguous.
points to any of those characters to create a pointer that points to any of the other characters in the array is valid.
Right. Okay, that makes sense then, because it's initialized as a string, which is an array. And if you're allocating it yourself, so I mean, like, but then if you've got car like malloc, car foo, like we know it's contiguous memory. I'm just like at the compiler level, does it have to track if it's contiguous and if it knows it's contiguous
or not? At the compiler level, the way this works is that when in doubt, assume it's valid. So in cases like this where you really can't tell, the way this works at the standards level is there are certain blessed functions, quote unquote, like malloc, that can construct objects.
But then if I've got my like fucking arena push.
Well, that will internally call malloc eventually. So.
Eventually, but it doesn't have to. It could also call it doesn't have to call malloc. I could have a big character array of like, I don't know, 64K. Because nobody needs more. And then I don't have to call malloc. I can just do a bump allocator. But I guess that's referencing the same contiguous chunk. So it's fine.
Well, at that point, what you get into is that in, I think, either C++26 or C++23, we have standard start lifetime as, which is what you're supposed to use for cases like this, where you're just dealing with raw memory and then trying to overlay objects onto them. So that would be the correct answer to that question as to how you would handle that. The de facto answer is that it's probably in a different translation unit, so if it doesn't get inlined, it's probably fine.
Because you have no information on it.
Yeah, but the thing is that like these very low level things as to, like, for instance, how is it that if you call malloc and just get a random pointer back, that's valid? How does it know that from malloc? And the answer is, well, in the standard, it just says that malloc does that. Basically, and the de facto answer is that it would probably work with any other function as well, because no compiler is going out of their way to check for that, even though it might technically be UB at some point. So, but yeah, it's not as rigorous as you might think it is. It's in some cases.
Yeah, just err on the side of programmer.
And this is actually, in some cases, not a particularly easy question, because particularly with how do you determine whether accessing something via a certain pointer is valid? There's ongoing debates onto how to best handle that, particularly in the presence of pointer to integer casts, because you can easily get a compiler to just miscompile something if you don't respect. It's called pointer provenance, and that's an entire subject where a series of seemingly valid transformations suddenly leads to an invalid program.
Yeah.
It's this is very like annoying and complicated stuff. So
Seeing if my roommate is around and ready to go, because if so, we're going to call it. If not, then I guess we can keep talking and working on stuff, because we have only done a tiny bit. He's offline in Discord, so we'll see. Oh, Snapchat. Snapchat got a response. That's not a yes or no answer. I texted him, and he said I'm not a cat. So I'll take that as a maybe. We're going to go with a maybe. Okay, so we haven't done a whole lot, but we've learned about classifying things. I'll have to make this not suck. This is merging things, so we'll just delete and say to do merge correctly. We'll get to that in a second. I'll clean this up a bit off camera. If it feels like I've got more that I'm comfortable doing on stream, I'll let people know. If not, maybe I chug through it over the weekend. Interesting. My brain has grown one size today. Well, thank you everybody for tuning in.
It's easiest to look at an implementation because this is the Cogen part of Clang is not something I'm terribly familiar with. I mostly do stuff in Sema, so.
Yeah, CodeGen is not my area of expertise either. I just usually hand it off to LLVM and hope for the best.
Well, the thing is also in Clang Cogen is IR generation. LLVM is an entirely different matter.
Yeah.
If you hear Cogen in the context of Clang, it's generating LLVM IR.
Yep. So, yeah, we're going to call it there. I am not going to commit this just yet because it doesn't compile, even though it's on another branch. But as soon as I get it compiling again, you can check it out on this other branch. So give us just 1 second. I'll be out in a minute. It'll be on the 21 C ABI. Yep, so you can check that in a few hours or tomorrow for any extra changes if you want to keep track. If you don't, check out me talking about it in the That's Hank or John Green. Check it about Discord. I'll be probably talking about it right here. And you can find a link to that in the description. You'll see an announcement if I'm going to do more live streams for it. But I'm going to go try to buy some food and figure out how to cook it. So you guys had a great time. Thanks for joining me, Eternal. That was great. Always a pleasure.